Assalamualaikum warahmatullahi wabarakatuh, and good day to our lecturer and all fellow students. Today, our group want to presenting our project for EFT 2283 about introduction to GIS. Our group take a strategy REE exploration through geospatial analysis. Rare Earth element REE, a vector to the global transitions toward green technology. It's because it helps identify viable deposits remain a significant geological challenge. To address this, our project demonstrates the application of GIS as a critical decision-making tool in geoscience. Today, what we can see, we have to utilize QGIS desktop for advanced data processing and web GIS platform for interactive data visualization. Why this is a collaborative effort. Each member has conducted as an individual analysis on a unique area of interest AOI, including Johor, Kedah, Pahang, Terengganu, and others, allowing us to evaluate REE indicator across diverse geographical terrains. We will now process to demonstrate our technical workflow and the spatial result for each regions.
For the technical demonstration, I will explain how GIS software and web GIS were used to process, analyze, and visualize environmental spatial data. So step 1 is map creation in QGIS, which is using desktop GIS. First, we started by using QGIS as our main desktop GIS software. So as a base map, we use OpenStreetMap, which provides roads, river, and settlement. So the next part is we zoom into Malaysia and focus on our selected area of interest. So this step helps us understand the spatial context of the study area before the analysis begins. Step 2, which is adding and managing spatial data. Next, we added spatial data related to administrative boundaries, and the data that we choose is the earth mineral extraction. So the administrative boundaries were downloaded from GDM, which have country, state, and district levels. So the data that we choose is earth mineral, and it was downloaded from the data.gov.my, and all the dataset were added as layers in QGIS. We then opened the attribute tables to examine the data fields and ensure the information was complete and accurate. Step 3, which is attribute editing and data preparation. To prepare the data for analysis, we edited the attribute table. So a new field was added to represent the earth mineral extraction data. So the data was cleaned and standardized, and the layers were renamed clearly for better organization. Actually, this step is important because spatial analysis depends on correct and well-structured attribute data. So the next step is step 4, which is spatial visualization. We gotta create the choroplast mapping. So after preparing the data, editing the attribute table and such so on, we create the choroplast map. So we use graduated symbology, and the color represent different levels of earth mineral data. So the darkest color indicate the higher value, and while the lighter colors indicate the lower value. So this visualization allows us to quickly identify spatial patterns and regional differences related to the where the earth mineral have. Step 5, which is web GIS publishing using QGIS to web. So finally, to demonstrate the WebGIS capability, we published the map using the QGIS to web plugin. So the plugin converts the QGIS project into a web-based interactive map. So when we upload the map into the WebGIS, so users can zoom in and out, focus layers on and off, click pictures to view attribute information. So this show how GIS results can be shared online and accessed by a wider audience without needing GIS software. So the GIS workflow demonstrate include importing and managing spatial data, editing attribute tables, creating thematic maps using symbology, and publishing interactive web GIS map. So this technical workflow demonstrate both conceptual understanding and practical digital skills in GIS from desktop analysis to web-based visualization. So this is the area of earth mineral extraction by state that we choose for all the 5 members of my group. So we have Johor, Kelantan, Perak, Kedah, and Pahang for the earth mineral extraction data.
Okay, hello everyone, my name is Dayan Ghazali, and for my part of the presentation, I will explain how GIS is applied to environmental and spatial problems, specifically in rare earth element or REE exploration. REE are essential for modern technologies like smartphone, electric vehicle and renewable energy system. However, finding and extracting them efficiently requires careful planning because their distribution is often scattered and associated with sensitive environment. This is where GIS becomes invaluable. GIS allows us to integrate multiple types of spatial data such as geological maps, soil types, satellite imagery, topography and water resource to identify potential REE in a rich zone. By analyzing pattern in mineral composition, evolution and landform, GIS helps geologists prioritize area and exploration and reduce unnecessary fieldwork. An important aspect of GIS in REE exploration is environmental management. Mining and extraction can have a significant environmental impact, including soil degradation, water contamination, and habitat disruption. GIS can map sensitive ecosystem, water bodies, and human settlements, ensuring exploration and mining are carried out sustainably and with minimal environmental harm. Another key application in risk assessment and spatial planning, GIS can model area prone to landslide, flooding area or erosion, factor that could affect both mining and operation and local communities. This help company and regulator make informed decision about the site selection, transportation, routes, and water disposal. Furthermore, GIS can monitor post-exploration environmental change by comparing satellite image and sensor data over time. We can detect land degradation or water contamination early and take a corrective measure. This ensures that REE extraction does not cause a long-term harm to ecosystem or the community. In conclusion, GIS is not just a mapping tool, but it's just a strategic decision to support system for REE exploration. It helps us to locate the valuable mineral resource, efficiently manage environmental risk, and plan sustainable operation. By integrating GIS into REE exploration, we can support both technological advance and environmental stewardship. That's all from me. Thank you.
Hello everyone, my name is Kelirin Madumil, and in this section I will compare desktop GIS and web GIS in the context of earth element or REE exploration. In terms of usability, desktop GIS is highly useful for REE exploration because it allows detailed spatial analysis such as lithological mapping, geochemical data processing, and overlay analysis. These advanced tools help identify potential REE bearing zone. However, it requires technical expertise. WebGIS is easier to use and is suitable for visualizing REE distribution, map and exploration results, especially for non-specialists. Regarding scalability,
REE exploration involves large dataset, including geochemical sample, geophysical surveys, and satellite imagery. Desktop GIS performance depends on local hardware and may slow down with large datasets. WebGIS is more scalable as it can store and process large REE dataset on cloud server, allowing multiple users to access and analyze data simultaneously. In terms of accessibility, desktop GIS is limited to specific computers and licensed software, which can restrict collaboration. WebGIS allows exploration data such as REE anomalies and prospect maps to be shared easily with team, stakeholder, and decision maker through web browser. Despite these advantages, there are limitations. Desktop GIS can be expensive and less efficient for real-time data sharing, while WebGIS may have limited analytical tools for complex REE modeling. Future improvement would include integrating advanced REE analysis tool into WebGIS and using hybrid systems that combine desktop GIS analysis with WebGIS visualization. Overall, combining desktop GIS and WebGIS provides a more efficient and effective approach for REE exploration, from detailed analysis to data sharing and decision making. Thank you.
Hello everyone, my name is Nur Aina Nabila binti Harun Zain. For this part of the presentation, I will explain the digital skill showcase applied in our REE element REE exploration project. So in this project, we use GIS software, specifically QGIS and WebGIS, to manage, analyze, and visualize spatial data related to REE exploration. So, for the first step involves creating a new project in QGIS and using the OpenStreetMap as the base map to provide the spatial reference. We then add the administrative boundary data for Malaysia, including the state and district boundaries, to define our selected area of interest for RE investigation. So next, we demonstrate the digital skills in the spatial data management by working with the attribute table. We edit the attribute table by adding the new fields and updating data values relevant to RE exploration. So this process is important because it links non-spatial information such as the geochemical or the locational data with the geographic coordinates. So after processing the data, we apply symbology and classification techniques to create a choropleth map. This map helps visualize spatial variation and highlight areas with higher potential for REE occurrence, making interpretation more effective. So in addition, we showcase our digital skills by developing a WebGIS using the QGIS web plugin. Through this web-based map, users can interact with the RE data by zooming, toggling layers, and viewing attribute information through the pop-up windows. This demonstrates how RE exploration data can be shared in an interactive and accessible format. Overall, the digital skills applied in this project include the spatial data handling, GIS analysis, map visualization, and the integration of desktop GIS with WebGIS. These skills are essential in REE exploration as they support data-driven decision making and improve efficiency in identifying potential REE-bearing areas. So in conclusion, the use of GIS and WebGIS not only enhance our understanding of REE spatial distribution, but also demonstrates the practical application of the digital skills in the modern geoscience exploration. Thank you.
In conclusion, our project highlights the transproactive role of GIS in modernizing RE exploration. Through our comparative analysis, we found that desktop GIS provide the necessary computational power for complex modeling and precise symbology, whereas WebGIS offers super scalability and accessibility for sharing findings with the wider scientific community. Reflecting on this 3-week project, we have we have significantly enhanced our digital literacy, moving beyond basic map making to mastering spread data layer and web-based publishing. These skills are essential for our future as a young scientist in a data-driven industry. We believe that in integrating advanced data analyzed into resource exploration is key to more sustainable and efficient mining practice. The conclusion to our presentation. That's all. Thank you for your attention.